So a couple of years ago, I gave a keynote speech to this conference when it was in Los Angeles about the supply chains for the goods manufactured in the Far East coming to the U.S. And digitalization has a lot to do with that. Is that if you have that information integration, you have a lot of feedback to continually be updating the matchup of supply and demand. So for example, it used to be that shipments were containerized in Asia and the shipping containers moved intact all the way to distribution centers across the US. But to do that, you have to commit how much is going where 1 to 2 months ahead of time, considering all the lead times to book a vessel and transit. Now what happens instead is that as the vessels are coming close to the port of entry, the computers are running and checking inventories in the distribution centers around the U.S. and they're making a reallocation. And the computers will be routed to a cross dock near the port, opened up, and the shipments repacked, reallocated, resorted, and create new container shipments from there. And that way there's a much better matchup of supply and demand. There's much less inventory. People have the goods in the store sooner. The retailer makes more money because they don't have to mark down stuff that's got sent to the wrong place, and so on. So it's a great example of, in supply chains, of how digitalization has really changed things. Well, we are not at zero cycle time and 100% yield and 100% equipment efficiency, and as long as we're not, there's something to work on, and I'm sure I won't live that long.
That's an excellent question, whether I visited Portugal or not. I have to admit that Portugal is my #1 country to visit, and I'll tell you why. Since 1942, every February, when the snow gets gray in Germany, especially in Munich, I take the airplane and my wife, and I come to Lisbon to visit Lisbon for a week or an extended weekend because we love the city, and that's true. So I've been for some vocational trips here as well, but for the city, Lisbon, I have to say, every year you can see me here walking around in February when snow gets gray. So this is a very long story about, because I have studied technical cybernetics, which is a very open way to study engineering. So it's all about systems engineering and mathematics behind that. So it's not bound to a certain technology, let's say like engineering science or manufacturing science. So when I finished my studies, I found out I know a lot about the theory, but very little about practice. So I decided to go to the Faculty of Engineering Science, and then I met people from industrial engineering, and they lit a fire in me. So I joined an institute, and I did my PhD work at an Institute for Industrial Engineering. And once I finished the PhD, I changed position, and I worked on several positions in companies in managing, let's say, people and managing processes, which is the core of industrial engineering. So after working for 20 years in industry on several management levels, I got the opportunities to come back to industrial engineering on the science side. So I decided to go back to university on the one hand, and the other hand to the Fraunhofer Society to work on applied research, especially in that topic. Okay, I believe the universities play a very important role in that case. For my belief, the core role of the university is to do the education of students, especially in terms of becoming an engineer, is very important. But ambidexterity, as I mentioned in my talk, so that you work on both sides of your brain, you work with both hands, it's very important. So you have to know what, let's say, your work will impact on the shop floor side, for example, so that you always say, when I do this and this and that step to have a new technology or a new process, there will be somebody who is not educated on the university who will be affected by that you know both sides of the world. And you have to get a clear understanding for all the social mechanisms behind especially manufacturing. Because people who have been educated at the university do not automatically work on the shop floor. These are other people. But they have a clear understanding. There's technology on the one hand, and there's, let's say, some social criteria on the other hand. And this should be focused by the universities as well.
I think that the whole Europe has some problems, and also other regions have problems with an aging population. And that means that you have too few young people coming into the work market, and too many people in the closing on to retirement. And that has economical implications as well as societal implications. So what we need to do is to interest the young people to consider the industry very nice and exciting jobs that are in industry. But we also need to reskill the people that are approaching retirement age to make them and to introduce them to the new concepts and new technologies. Technology and automation can only support the actual productivity increase. I think that there are some studies done about this, but it will not be enough to automate, and it will take away some of the tasks that the people are working today, but it will not radically change. Like the McKinsey study was mentioning, only 5% of the occupations are probably going to sort of disappear, and the other ones will be very reliant on that you actually learn new things and adapt and try to think about how can I use the new technology to create things and values that weren't there before. So I think that it's not really an ethical question. I think it's a necessity to use automation in a good way and try to see how it can support people rather than replace people. If you look at all the technology around you, most of it is in interaction with you rather than being replacing you. I think that the collaboration using high-speed communication technology, there's endless opportunities, of course, but it will cost. I mean, we will try to find new ways of approaching how to price things and to sell things and to make business cases out of technology and products. There are some really interesting discussions on how to use platforms, technical platforms, to communicate and to lift the communication in a way that you can actually use, like you said, you can sit in one part of the world and you can actually have interaction with others. But it's not really enough. I mean, if you ever used a video conferencing system, then you realize that this is not the same thing as being there in person and talk to the people. So there's still a lot of things that cannot be replaced by technology. It can be complemented, but it cannot be replaced.
This is actually my first time in the south. I had the opportunity to visit first Porto, Guimarães, and Braga. So I think it's a very vibrant country, and I think you have a very sophisticated highways and bridges system. So I think that with computers and industrial engineering, right, which is basically how we define nowadays Industry 4.0 revolution, which is like combining information technology and operation technologies to try to make things better. I think that bringing this to developing economies such as Portugal, or even economies such as Mexico, for where I'm coming from, gives a different perspective, right, on how we need to adapt these technologies to the realities of our countries and make the best out of them. So I think having this conference here and having such big achievements of having almost 45 countries represented here from the 5 different continents, that really enriches the discussion. I think that's a new research perspective that engineers were starting to develop, right? That was a little bit one of my aims of my keynote, to talk about social sustainability of manufacturing. And when it comes particularly to your question, right, it's about how we can better design socially responsible, ethical automation systems. I think at this point there is no clear answer. I think it requires interdisciplinary, multidisciplinary work, where we would need to sit down with people from social sciences to really start crafting those design principles, so other engineers working in the automation world could work on that. And we already seen a little bit on that, right? Is when we talk about autonomous vehicles, right? And we have to teach the machine in case of making a decision between, perhaps, I don't know, there's a group of people on the right side which are elder, right? And then you have a smaller group of people on the right side but younger. And then if the car would need to collide with one of these two groups, right? What would be the decision of the computer, right? Of the artificial intelligence to do this? And it's challenging, right? Because all life are precious, so it's difficult to design for that, how you teach a machine to make a decision like that. I think there's no answer now, but I think those are part of the challenges that we need to start to work in the future. I think especially like industrial engineering, which is a discipline oriented to integrating different technologies to create production systems, right? I think we're having this biggest challenge of how to make the systems ethical, or even, here's another example. We talk about nowadays about machine-to-machine communication, right? And we want machines to negotiate, right? And if a machine feels that the throughput that he's having would not allow him to deliver on time, we want that machine communicates with another machine that perhaps it's not fully being using its production capacity, and help with that delayed, right, in time by helping to produce. But legally speaking, today laws don't allow two machines to create a contract, to negotiate, right? We always need by law to have a human agreeing in shifting production from one production line to another production line, perhaps within the same company, or shifting to a different factory. So I think there's a lot of very interesting projects to be done, bringing people from social science, bringing people to law, to really implement in a socially responsible, ethical way all these new automation and smart technologies.